Thank you all for coming this afternoon. I lead the distributed training efforts at machine learning platform at Zoox, and I'm also trying to bring Ray-based data gen processing as well as LLM evaluation workloads into the platform. Today I'll focus only on Ray and will not talk about the distributed training. So why we need this kind of architecture or system in place? Because we have several post-training use cases, and I will talk about them. And we'll talk about the solution stack and some of my experiments. Due to company policies, I cannot disclose exact data points or exact cost or exact data sets, but I will talk about an example which is very close to our use cases. And then we'll show, try to get some live demo working if things work well. All right, so when we need these kind of Ray-based evaluations, so we have lots of LLM and vLLM model being trained, and as you know, we are a robotaxi company. We have several different kinds of inputs, texts, images, custom lidars, sensors, various kinds of multimodal data. We have an established distributed training setup now, and we are trying to go towards how to make the models being evaluated at scale. So as you can see on the picture, we create a lot of checkpoints, and each checkpoints are multi-GB in size because they're essentially from open source models found from Qwen2.vl, and we fine-tune on them. So, and we cannot add, and every training loop has a validation as well as a test step. Now, evaluation of these checkpoints are becoming costlier because if we include that test step inside the training loop, it adds time to the runtime of the main training loop. And since we use very costly machines like P5ENs, 48x large, and P6s, 200, which are way too costly, and if we introduce the test step inside that, it's eating into our training time. So the push towards us is, let's offload this evaluation workflow in a separate process, and there are many ways we can do that. And Ray being one of the enablers how we can do it. And we do not keep it as part of the training loop. So I talked about the business justification, why we need that. And then next point is what possible technical directions we can take. Let's say when all the checkpoints are created, there are two ways. Either you wait for the training to complete and then kick off a post-processing job that takes all the checkpoints and run evaluation on top of them, or you choose to select some of the checkpoints based on your training metrics, out of all 50 checkpoints, these 10 look good from the model metrics, and then we choose those 10 to evaluate. Or the evaluation can be fired up asynchronously. What does it mean? While the training is running and as a checkpoint is created, we fire off the evaluation. We just don't wait for the training to end. So there are many ways of doing the evaluation. Whatever way we choose, we will ultimately come down to the picture here that we would try to leverage cheaper nodes, smaller scale machines or GPUs to do the actual evaluation while we reserve the costlier machines for the training. And we should be able to do some of the processing or pre-processing or post-processing layers independently of the GPU layer where the vLLM is hosted or the LLM is hosted. So we should have a heterogeneous compute. So two criteria. We should have a heterogeneous compute, and we should also be able to scale up the stages independently. All right. So how would that structure look like? So we choose Ray. We are very prolific users of Ray Train so far. We haven't used Ray Data or Ray Data LLM so far to the extent we want to do. But since the new APIs for Ray Data LLM came out, we have decided that we will now push towards this direction. So that if you can see on the inputs, we have like images and videos. And once we read these images, we can play with the batching mechanism of that. And then we have the model inference layer. And then we write it out in some S3 bucket, or we can do also some post-processing. Ray provides a great setup ecosystem so that we can have this heterogeneous compute all at the same place. Some workloads running on the CPU, for example, the reads. Some workloads run on the GPUs, for example, the inference. And some the post workflows like writing also works on CPU. The good thing is we also have custom in-house LLM evaluation toolkits or functions or libraries. We can also add it to the post process. Or we can also add a powerful LLM as a judge, as a plug and play in the post process. So we can scale the post step of the inference or the pre-process step of the inference, like independently of each other. And currently we use vLLM eval kit, and we are pretty much aware of how vLLM works. It is pretty straightforward for us to migrate to a Ray-based workload where we distribute things. And also Ray Data LLM comes with a solid integration of vLLM and OpenAI compatible endpoints. So some of our engineers are very good at like using the OpenAI compatible endpoints, but some engineers want just scripts. So we can as a platform engineer or a enabler, we can cater to both kinds of engineers and workloads and their processes. And we do not want to interfere or ask them to rewrite things. We would just try to bring ourselves and scale in their working process without disrupting them too much. All right, cool. So once we have these established, I think the brightness is a little bit low on the screens, but I will talk through it. Maybe I will try to demo it as well. So these are my learnings and experiments, and we are still learning on the way. Maybe in a couple of months, we'll become pretty good at it. But let's say if I were to start, how would the story play out? I'm a new engineer. I don't know how to write this kind of routines. So how will I approach? So first of all, we will start with the basic first pipeline, very naive pipeline. Like there are 4 steps. I load the data set, I create an LLM processor, and then I caption the data sets. So what is captioning data sets? Captioning data sets mean given, let's say, our robotaxi captures videos and images. Based on this scene, what are the objects in the scene? What are the how many people are pedestrian in the scene? Is anyone crossing the road? Should the taxi go forward, backward, or stop, or take some other decisions? So I'm giving you a generic example, but there are specific nuances inside Zoox, which I won't be discussing right now, but this is a close enough example. So this example is trying to mimic what we do inside, what our engineers do. Essentially take a multimodal input and try to understand the scene. So what are we going to do? If these 4 steps are defined, then what are we going to do on those 4 steps? So first of all, we should have a caption process method. What does caption process do? I will show you in code. It's very hard to show things on slides, but these are like generic structure. So caption process, as you can see, it creates messages in the OpenAI format and passes some sampling parameters to the vLLM. What's the next step? If I do pre-process, then the logical next step is, okay, I should also have a post-process. I should also post-process and add my LLM evaluation logic into that and the output. And how do I scale it? This is where we use Ray Data LLM integration. We use the vLLM engine processor config, and the model source will be a Qwen model, which I'm going to show in a bit. And the build LLM processor is the one who is tying the pre and post process. But there are shortcomings in this, and I will talk about what. But let's say we start here, and how far can we go? All right. Before we go there, let me try to show you. Also, the codes are available on GitHub. It will be on my page. I will share in the code. So let's see. I will not walk through the code. It's not possible realistically to do it. But when I share the GitHub, you will find there are like many 4 steps. Oh, it's not sharing the screen.
Presentation?
Yeah, my presentation is, I need to switch between presentation and code.
Oh, okay, then yeah, just go back down here and then just click it on there when you need to go back. And then just go from current slide to current slide.
No, I need to show the code as well.
Yeah, so like when you need to go back.
Okay.
Oh, I see, you're trying to show it over there.
Yeah.
Sorry.
Oh, can we just mirror it? Instead of extended,
Yeah,
can we just mirror
that's
it?
fine. Give me 1 second. That's not what I wanted. There you go.
All right, cool. Okay, cool. So you will find this is image pipeline V1. So what I'm trying to do is I will try to actually live run it and see if it works. I ran it yesterday night. It worked, so hopefully it will work now as well. So what it's trying to do is, if we minimize this a little bit, so I'm trying to say, for the demo purpose, I'm trying to take 10,000 images and try to kick off a run on top of it. While it's running, as an engineer, I want to investigate what's going on inside it. Just running on the console, I really cannot get any insight at all. So while this job is running, so what I have done is I have also configured like Prometheus and Grafana in my local Mac. So we can see it live, what's going on. So I will start the Prometheus as well, and the Grafana as well. So now we have 3 systems running in the same, on my Mac. Now what I did is I went to, in order to install Prometheus and Grafana, you should follow this link. They have a very good setup. I'm not going to go through this link, but just to let you put the pointer here that once you have Prometheus and Grafana up from here, we can port forward and ask Prometheus that, am I able to see all my matrices, metrics? Looks like I need to redo the port. This is the danger of live coding. All right. Cool. All right. So we have, I have created the Ray dashboard as well. So as you install Grafana, you will find all these Ray dashboard being created. So the point I'm trying to drive is, if you go here and then look at it, you should be able, this is where you start your optimization processes as you look through your Ray dashboard. So when we look at this job, remember I started a very small job. I think it's taking quite time to load, but I will click on each of these tasks and show like how should we approach for optimizing. I think I will let it load, and I will talk through it like as when it comes up. Okay, cool. So when we look at it, that Grafana dashboard, you will find that it will not work out of the box. So what happens? What are the challenges to make it work? And I have been working with Anyscale team, and they are going. We are working on fixing that. But I will talk about this piece a little bit. So when you enable this Grafana chart, you will see that the LLM metrics are not coming in, although the Ray data and Ray default dashboard will come in, but LLM metrics will not be coming in. The reason being, we have to patch the vLLM stage file. If you look at this file here, this is a very important file to note. It will show you all the stages that Ray Data LLM injects or builds, for example, like tokenizing, templatizing, and things like that. And ultimately, it spins another stage to vLLM. So if we go on to the UI again, so we will see all the stages are here. If you look at the build LLM processor, this is a very important file. It should show you all the stages that the LLM processor is going on, and this is our focus area where we can tune. If you open the vLLM stage as well, it will create this vLLM engine wrapper, which is, if you have worked with the vanilla vLLM package already, then this piece would be pretty straightforward and you should be already aware of this, like how am I building the vLLM engine. But the only issue is here, although it's building the engine, vLLM also emits metrics. But the metrics emitter or the processor is not hooked. The vLLM emits metrics in some port. Ray also has his metrics in some other port, but we have a Grafana. We want to merge both of these so that we get a unified way of seeing things. In order to make that happen, so what we need to do is we have to add a Ray Prometheus stats logger. Let me maximize it. We have to add a Ray Prometheus stats logger so that it massages the vLLM metrics, makes it Ray compatible, and exports it at the same port where all the other metrics are exported. So let's go back here. If you check here now, if you go to, let's see. Wow, this is a live demo and failed. Anyway, so what will happen is I have a screenshot of that. Let's take a look at that. So we should get some metrics around this. Like you will be seeing how many tokens are being throughput and what is your cache utilization and how much token latency is going on. So based on these figures, like how much cache is being utilized, you should be able to tune whether your job needs like more processes on the vLLM side or more processes on the Ray dashboard side. Since the code is not working, so let me actually walk through the optimizations that I made. So once you enable this, everything should be working fine, and you should get some captions like this. We are not going to detail into these captions, but these are like, our focus is not how the captions are, but this is how we would do it. So now, once we have this naive way of doing things, what is the summary of that? We asked Ray that, okay, load this data set for us, use an unified processor. We are not going to control it at all. Just let Ray decide what it is supposed to do, and then we have a post process. So what are the options now? we can do repartitioning of the data set. Why? Because we feel that if we can add more CPUs, let's say your data set has a lot of processing, you need to repartition that data set into multiple workers. We feel if we can repartition and add more workers or more CPUs to that, you can make it even faster. So this is empirical strategies. I will not go through each of these, but based on whether it's CPU or memory or outbound, you can try out and start with these empirical processes at the beginning. Now the next step is, okay, I repartition the data, then what next? If I show you the first code, it was like pure just map process. I can now say, okay, I repartitioned it, I would now do map batches instead of just map. So, and while I do map batches, I would also focus that I want to give 8 workers, I want to give 4 CPUs to each worker. So on the picture now you see there are 2 blue boxes, the pre-process and the, green boxes, the pre-process and the post-process are being separate from the yellow box. We have separated it out totally. And if we do that, let's see how the second pipeline would look like. The second pipeline would look like there are a couple of more steps added now. After the load data set, we have now partition, pre-process, as well as step 6 added to the mix. And how each of these steps would look like, let's go through the partition data set, create caption. We still have caption process method, but it's a batch method now. And there is a new method for pre-processed data set that says dataset.mapBatches, use that method. And I also provide num CPUs and concurrency to scale it like independently. And similarly, similar logic would be extended to post-process. The only difference now comes on the create LLM processor is, if you look at the build LLM processor on the last, the pre-process and post-process are none, because I'm not using the default Ray construct. I'm specifying what I need to do. I'm taking full control of it. An easy way to see that is if we take a quick code comparison, we can do it quickly and get some idea what's going on inside. We can check that. Now we have like pre-processing steps, as well as now we have a batch method and things like that. Okay, so I will move on from here. So let's say I fixed it. What else? What else can we do? If we fix it, then what happens is I should obviously see some improvements. These are the improvements I saw in my cases, but don't. These will be not applicable for all use cases for sure, because it will depend on the data set and your GPU instances. But take the learning that this is how we are going to optimize it, and this is the strategy that we are going to take it. And you should also be able to like visualize once you have these metrics updated. Clearly, version 2 is more better than version 1 because I have optimized the sizes. I have also added like chunk prefill and batching on the vLLM side. So optimization on both sides should also always lead to improvement. Coming back to here, like what happens if we need more? Let's see, we have custom libraries. For example, I have given the example for here is like QuenVL utils. Our customers uses Quen 2.5 VL model, so they have to use these QuenVL utils, which does pre-processing and post-processing of images as well. How do I plug in to that? And since it's the pre-process and pre-processing of each image or a video can be costly, what else can I do? I cannot keep on loading the tokenizer for every sample of the row or every data point. So there has to be some mechanism for that. So the way to do is using a class, an actor with state management, and then we use the VL processor and process vision info method inside the code. And I will show you an example how to do that. So we are building the third pipeline now. Now I'm showing on the left a caption preprocessor. It's a class. And take a look at the init method, which is initializing the Qwen 2.5 VL processor, and it is initializing once. So for every num blocks or every block of records, because I repartition the data set, this actor will only initialize this processor only once. And the call method is implemented. We have implemented the chat template method, process vision method. So we are controlling the prompts and the inputs to the vLLM multimodal. And then the entire pipeline would look like pre-process and post-process. The structure remains same, but instead of having a method, we are now using a class. And we are making that actor scale with num CPUs and concurrency. And the second part, which is very important, if you have to make it work with the existing Ray infrastructure, we have to understand what vLLM expects. Because I am designing the prompt as well as the images, videos by the process vision info util. So there are a couple of changes I need to make. That I cannot ask the LLM processor to apply the chat template because I am doing it. I also do not need it to tokenize it. And I am also saying that I am processing the image myself, so let's not the default processor kick in. And in order to discover these finer details, you need to go through the vLLM stage and vLLM processor, and also along with that, the multimodal inputs doc from vLLM. Then it will be clear like which is to be enabled and not enabled. So the question is, we use Ray, but when shall we not use it? So if your request is single, like latency matters most, you are not doing it offline, you are not focused on throughput, then use it. Otherwise, go for Ray serve. If you have small jobs like 1,000 images, it doesn't make sense because the overhead would be exceeding the benefit. You can just write up a simple shell script or Python. And if you have like custom CUDA kernels on the pre-processing layers, which is using GPU actors, probably it may not be a fit. I haven't tried it, but I think that will be our next goal, how to do it. So the learnings is like start with small, build the first baseline, check the Ray dashboard and Grafana dashboards, and then slowly, incrementally build on top of Ray modifications as well as the vLLM modifications. And separate the concerns. Pre-process, post-process, actual GPU workload should be separate. And try to maintain state. Don't keep on asking Hugging Face or requesting Hugging Face for token. Otherwise, you will get the rate limit errors. Try to limit that by state management through classes and init methods. Yeah, it cannot be completed with help from any scale. Two folks, Nikhil and Korush, worked with me, and while we tried to come up with this use case, they also fixed bugs, and also like there is one more bugs to be fixed, but fundamentally I acknowledge their help. Yep, that's all. Oh, the question was, why did we have the pipeline 3? What's the key benefit? The key benefit is, let's open the pipeline 3. The key benefit here is, so we are using a processor called Qwen 2.5 VL processor. It's from the Qwen team themselves. It is optimized and very particular for the Qwen 2.5 VL model. So let's say our team has a very particular way of processing images, and they necessarily it's not satisfied by Ray or Ray Data LLM, and we want to plug that in. So this is how I take full control of it instead of relying on default Ray Data processors. So for example, here if you see the prompt, we are making this prompt using that processor, and then we are making these images and videos. It's like an array. It will go as a multimodal input array, and vLLM understands that. In order to make it, we should be using this third-party library, and this is how we can integrate it.